Hello, today we're going to talk about standard, deviation, and variance. So let's get started. This is chapter 12.2, and you'll find it in your book on page 757 and through 763. The first thing you probably want to know is what we're doing with this video. We are going to copy the notes and the problems from this video. So there's going to be a little bit of notes. There's going to be a few problems. You're going to do them. A lot of the work will be done with the calculator. So you're obviously not going to show those steps, but just make sure you copy the problems. If you had to make a histogram in any one of these or a box and whisker plot in the next couple videos, you'll copy those from your calculator as well. And then don't forget to ask a question about the lesson. All right. So standard deviation shows how the data deviates from the mean, from the average. Okay. So is the data good? Is it very close to the average, which means it'll have a small standard deviation, or is it far away from the mean? So are some of these values very far away from the mean, which means your data is more spread out, so maybe the mean is not as reliable of a measure. So what you're looking for today, this symbol right here is called the sigma. It's sigma, and it's the symbol for standard deviation. If we square sigma, or sigma squared, is a symbol for variance. We'll be looking for those today. And again, I kind of set this up here. A small standard deviation compared to the mean tells us that the data is very close to the mean. And a large sigma, large standard deviation compared to the mean, again, I'm always comparing it to the mean, tells us the data is more spread out. All right, so that's what we're looking at. Again, how far, how close, how compact is the data, or how spread out? That's what standard deviation is going to tell us. Okay, so here's our first problem. We're going to find the standard deviation and the variance for the data set. All right. So what I want you to do right now is pause the video and copy down this set of data. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points. Okay, so pause this video, write these down, and then we're going to go to the calculator. All right. Okay, so just so you know, on your calculator, you're looking for the stat button. You're going to push that first. You probably want to take these notes, just jot them down quickly. Then you're going to hit enter, and that's when you're in the edit function. And you're going to enter all the data into the L1 column. So all of this data is going to go in the L1 column. You just push 9, then you're going to hit the down arrow, push 10, hit the down arrow until you've entered in all the data. All right. Once you have all the data entered, you're going to hit stat again. You're going to hit the right arrow button. All right. And then you're going to hit enter, enter. And that's the one variable statistics. Okay, so that's going to give us that all of the data we need. In fact, what we're doing right now, we're going to do over and over again. Essentially these same steps here. In this video, I'm going to show you. I'm going to keep going back and forth to the calculator, showing you how I'm entering data in, and then after this video, I'm just going to have the data entered into the calculator, and we'll talk about some different ways to look at the data with a little more depth. Okay, so here we go. The first thing we're going to do, actually, I'm going to pause the video and set up the camera so you can see the calculator. Okay, first thing you want to do is obviously turn your calculator on. And remember the directions said we're going to hit the stat button. And now we're in this edit feature. Stat is right there. We're going to hit enter. And now I already have data in there. In fact, it is the data I'm looking for, but you may come across your calculator already has stuff in it. So let's talk about how to get rid of it. You just have to hit the delete key. So I'm on the very first entry. I'm just going to hit delete until it's all gone. There we go. And now you got to make sure you're in the L1 column. All right, and we're going to start entering that data. And the first set was 9. I'm hitting down, and then I'm just going to type it all in. All right, so I have them all entered in. There were 15 data values, and I have 15 of them, so we should be good. All right, and now I'm going to hit Stat again. I'm going to hit the right arrow to get into the Calculate menu, and the first choice, one variable statistics, is exactly what I want. All right, so I'm just going to hit Enter, and I got to run that program and hit Enter again. So here's what we're looking at. Remember that X with the bar over it, X bar is the mean. This is the average. So the average of all the data is 9. Okay, and then this sigma value, sigma X, this is really what you're looking for, is 1.86. Okay, so those values we would write down. So if I had a sheet of paper, I might write down my mean was 9, and my sigma, my standard deviation, that's what that means, is 1.86. Now, if they ask me for the variance in the direction, I'm going to use the 1.86 to find the variance, because remember that variance is sigma squared, or the standard deviation squared. All right, so I'm going to type in 1.86, and I'm going to square that, and I'm going to get, so going back to my paper, my variance is, what do we got here? 3.45. Okay. Now, so that's how we're getting that data. And when I look at this, with the mean of 9, okay, and a standard deviation of 1.86, that means on average, the distance away from the mean, the data is only 1.86. So I'd say this has a small standard deviation compared to the mean. So a lot of my data is very close to the middle. So I would be willing to guess that my data, when we get into these histograms and stuff, is going to be stacked up mostly in here with a very small amount of outliers out here. Okay, and so that's what our standard deviation is telling us. All right, now let's go back. I'm going to pause it again, and we will go back to our PowerPoint. All right, so we were looking for the mean. We said that. This is what standard deviation is on your calculator, this sigma x, and then again we had to square it to get our variance. All right, and there were our answers. I think we said 3.45, 3.5. It's depending on how you round, you're good to go. All right, let's give another one a try. All right, so I'm going to pause this again, and we'll go back to the calculator. Okay, so let's go review entering data in. So we're going to hit Stat. We're going to edit our data. We already have data points in there, but we are going to get rid of them by hitting the Delete button until it's all gone. All right, and in our data, we had the numbers. This was hours that girls on the tennis team worked each week. So the first one was 10, and then 12, and then 0, 6, 9, 15, 12, 10, 11, and 20. All right, I kind of already see a few outliers here. It looks like we got 20 and 0. Those are pretty far away from everything else, but let's see what happens. Okay, I'm expecting a pretty high standard deviation here. All right, so I'm going to hit the Stat button again now that it's all entered. Now I want to calculate this. And here's what I'm getting. The mean for this was 10.5, so the average weekly rate that everybody worked was 10.5. We add them all up and divided by, I think there were 10 entries. Yep, there was. And then I can scroll. Oh, actually, I don't need to yet. My standard deviation is almost 5, though. So we are all over the map. If our mean was 10 and our standard deviation is 5, that means most of the data was halfway away, right? So you're thinking most of the data was between 5 and 15. That's a pretty big spread. So that's what we want to talk about when we look at these types of problems. All right. So we got 10.5 for our standard deviation. I'm sorry, for the average, and the standard deviation was 4.98. The data was spread out mostly due to those two outliers of 0 and 20. Okay, so that's what we were looking at there. Now, let's take a look at comparing some data. So when we compare data, we'll be using the mean and standard deviation. So we're looking at the mean, we're going to compare those means, and we're going to be comparing the standard deviation. Okay. So here is the first problem. And what I'm going to do to save time, because I've only got 5 minutes left, is I'm going to enter in the data. So this kid is golfing. Here is scores at Table Rock, and then here is scores at Blackhawk. I'm going to enter in the data and get the mean and the standard deviation for his scores at Table Rock and his scores at Blackhawk. We're going to have to do that separately. I'm going to do it twice. All right. So I'll be right back with the calculator. All right. So I've entered in the data. I'm going to hit Stat. We're going to calculate. And I'm going to write this down. So this was me on my paper, and I had to really compare these two sets of golf scores. All right, let's call this like number 2, let's say. I would say that the mean, his score, he's a pretty good golfer, is 80.3, and the standard deviation is 1 point, we'll just say 1.4, so the standard deviation. Okay, so I wrote that down, and what that means to me is his average score is 80.3, and most of the data is within a stroke and a half of 80. Okay, essentially. All right, so most of that data, the average distance away from the mean of every data point is 1.4 strokes, or almost 1.5 strokes. So that's pretty good. Now I'm going to pause it again, and we'll compare that to the other golf course. This was, just so I don't forget, this was Table Rock. I'm going to do the same thing for Blackhawk. All right. All right, so I've entered in the data, and I went to the statistics and I calculated it. And so his mean at Blackhawk, as you can see, is 82.9. Still pretty good, but not as good as the other place. And here's where you can really see the change in the standard deviation. We're going to say is 3.9, almost 4, 3.96. Okay, so almost 4. All right, and so what that means is I compare them is obviously we can see average-wise he's scoring better at Table Rock, 80.3, and his scores don't change much from time to time. They're right around 80 every time. Where here, the scores are a little higher, almost 3 strokes higher. All right, and the variation, the deviation, is a little more spread out. Okay, so his scores might be a little worse at times, and even a little better than 83, essentially. All right. So he's a little more erratic at Blackhawk. Maybe it's a longer course and he's got to use some different clubs he's not comfortable with. Either way, he is scoring more sporadically at Blackhawk, and he has a higher average score. So his better course to play for him anyway would be Table Rock. All right. Remember, in golf, we're looking for lower scores. Okay. All right. So let's take a look at the next one. All right. So what I'd like you to try on your graphing calculator is compare these two lineups. All right. I believe, yep, these are swim teams. Okay. So these are the recorded times for each lineup. Let's see. You can see the answer here, but see if you can get the same thing in your calculator. All right. And see what their average time is and how much it varies. Okay. And I think you'll see a difference there. All right. So this is the first section, or actually the second section we covered in chapter 12. And it's going to be calculator heavy because there's a lot of math to do in these. So really your job is to get comfortable using this graphing calculator. I hope this video helped, and I will see you guys next time.